Greetings to all. I'm Chiraag, an undergrad at PES University. In this video, I'll be talking about my task 2 as a data science and business analytics intern at the Sparks Foundation. The second task is to build an unsupervised machine learning model to predict the optimum number of clusters and visualize it graphically. This problem involves 5 variables, out of which are the 4 characteristics or parameters of the flower, the sepal length and width, the petal length and width, and finally the class of the flower in which we want to cluster our dataset into. I'll be making use of the k-nearest neighbor model to cluster the dataset into ideal classes or clusters. This model is based on starting with a random point for each class and using gradient descent to reach to the centers as a centroid for each type of cluster or class the data is to be clustered into. The whole code was written on Google Colab in Python language. So the first thing is to import all the required libraries. The k-means model is imported from Python's sklearn library. I imported pandas library for functions such as file reading, in our case CSV file, and data loading. The matplot library is imported for plotting the dataset and for visualizing the clusters in the dataset. The dataset itself is imported from sklearn.datasets library. Dataset is called load iris, which has details about the iris flower kind. And we want to classify or cluster data into different kinds of iris flower based on these parameters. A data frame using pandas is created and stored in the variable irisspec, and using irisspec head, the first few values of the dataset are printed as a table. The next thing is to decide the ideal k value required for the dataset in hand, whether to start with 2 or 3 or 4 or any other value. This value of k decides how many centroids we'll have in the dataset. The best method is the elbow method, in which for a range of k values, in our case 1 to 10, the sum of squared errors, which is basically the sum of distances of each point from the centroid for each cluster, is calculated for each k value in the range defined. So sum of squared errors versus k values are plotted, and the value of k at the elbow is selected as the ideal value, and in our case it is 3. Next, an instance of k-means model named km is created with k or clusters value specified as 3 obtained from the elbow method. A prediction of optimum clusters is made by fitting the model onto the data frame irisspec using km object. So the prediction has been performed and is stored in the variable prediction. Next step is to visualize the same to give a better picture of what is happening. So the predictions are stored in the dataset under a newly created cluster column for each value in the dataset. For visualization purposes, since 3 clusters has to be plotted, the data frame is divided based on the 3 cluster types and are stored in separate variables. These variables are then used to plot the clusters in the dataset, and for simplicity, only 2 features, the petal length and width, is used for each partition, and making use of the matplot library, the clusters in the dataset irisspec is plotted. It is clearly visible that 3 different clusters exist in the dataset, which signify that the dataset has 3 different kinds of the iris flower. That was all about fitting a KNN model to the iris flower dataset involving multiple parameters. Thank you.